This is the Building Automation Monthly Podcast with Phil Zito, episode 174. Hey folks, Phil Zito here, and welcome to episode 174 of the Building Automation Monthly Podcast. In this week's episode, we're going to be talking about how to troubleshoot a building automation system. This is a topic that I've been wanting to do a podcast on for quite a while, but it's a very difficult podcast topic. Because troubleshooting, at least for the longest time, I thought was truly an art. If I'm being completely honest with you, I thought that I was just blessed with good troubleshooting abilities. Yeah, that sounds really egotistical. It makes me sound like a major ass, but it's what I thought. And I thought to myself, man, that's just a gift I have. But as I started to really look around and think about the topic, because a lot of our students have asked us, like, are you going to do a troubleshooting course? Are you going to help us figure out how to troubleshoot? Because it's so difficult. As I started to think about it, I realized that every time I approached troubleshooting a problem, I would take one of two approaches, and it was the same approach every time. And so it wasn't actually a gift. It wasn't anything unique. It was just, there was a pattern that I don't know how I developed it, but I did. And doing this pattern again and again caused me to be able to troubleshoot situations and problems much easier than it seemed other folks were approaching the problems. So with that being said, that's what we're going to discuss in today's episode. We're going to go through troubleshooting. We're going to talk through kind of the two troubleshooting techniques. We're going to go through a lot of scenarios. We're going to look at controller level troubleshooting, supervisory level troubleshooting, and server level troubleshooting. Now, I will tell you that troubleshooting, especially most of the troubleshooting you'll do, falls into two domains. It falls into the HVAC domain, and it falls into kind of what I would call the technology domain. That's kind of a hybrid of IT and programming. Now, for a lot of you out there, that is a challenge, because what happens is a lot of folks are brought into the industry either from being a mechanic and moving into controls, or by just coming straight out of a university or a 2-year program. And oftentimes they're not equipped with what they need in order to address a more service-oriented role. Sure, there's plenty of stuff out there for install, but not so much for service. So what I am recommending to you, and it's the sponsor of today's show, is our HVAC Control Sequences course. I encourage you to go and check out that course. It's going to be at buildingautomationmonthly.com/174. If you're looking for a course that will teach you how HVAC systems should be controlled by a building automation system without sitting there and spending 5 years as a mechanic or going through trade school or spending a lot of time just learning on your own, if you want to learn in less than a week everything you need to know about HVAC controls from a building automation perspective to succeed in your career, then this is the course for you. And I highly encourage you to check it out. All right, so with that being said, what are these two troubleshooting techniques that I'm talking about? Well, they're actually really simple techniques. One is called input to output. And essentially what you do in this technique is that you start with the input and you work to the output. So for example, if you're troubleshooting a space temp issue, you start with the space temp and then you work to the output that affects that process variable. So let me define some terms real quick, just so we're all on the same page. If you've been listening to this podcast for a while, you probably know these terms, but for those of you who are maybe just tuning in, you're new, these are terms I really want to define. So we're going to hear process variable, right? Process variable is what you're controlling. It is the variable that you're controlling with a process. So basically what happens in building automation inside a controller, right? Inside a control system is that you have an input, And then you have a process that happens inside that input. It may be a PID loop, it may be a sequencer loop, it may be a temperature logic block, whatever. But that process happens, and that process drives an output. A common example of this would be VAV damper control. You have an airflow sensor typically built into the VAV controller, connected to an airflow sensor on the VAV box that senses velocity, pressure, it senses your air, you get an air calculation, and then that drives typically a PID loop, and that PID loop is your process, and that loop drives an output, which is your damper. It's a direct closed loop feedback sequence. All right, so when I say input to output, that's what I'm talking about. That is that troubleshooting technique. We start with the input and we start working through it to the output. Then there is output to input, which, as you might imagine, is you start with the output that drives the process loop and work back to the process variable. Now, where this gets complicated, where a lot of folks get mixed up, is when you have nested loops. And what I mean by that is, so for example, in a VAV box, you are often controlling the zone temperature, but you're controlling the zone temperature by controlling airflow. So you'll have like 55 degree air coming from an air handling unit. We're talking about cooling only box, right? And that VAV box is cooling only, and you are driving to zone temperature set point. And so you've got a set point, and you've got your process variable, zone temp. Those are going into a PID loop. They're calculating a 0 to 100% output. That 0 to 100% output then goes into what's known as a scalar object in your logic for your programming, for your controller. So what happens is that scalar object then scales between min and max CFM, which now so you've got this primary loop, which is zone temp, driving an output of a PID block, which then that output drives to, guess what, a scalar block, which then resets. So maybe a scalar block, maybe you call it a reset. It resets the CFM set point, and then you are now driving CFM. So you're driving your CFM based on a calculated set point that's reset off of that zone temp PID. You're driving that CFM set point, and now your new process variable is CFM off the airflow sensor, and you're driving a output, which is a damper output, off of that secondary PID loop. So that's a nested loop scenario. And so what will happen oftentimes is when people are approaching these troubleshooting, they will go and in a nested scenario, they will go and potentially look at the damper and say, oh, okay, I'm going to look at the damper and its CFM set point, not taking into account that there is a greater loop at a higher level that is actually driving that CFM set point. So there's all these variables that we need to be cognizant of. So that's why you can switch and basically flip and flop between input output or output to input. So with all that being said, you should have a solid understanding of what I mean by these terms. Now let's dive through some scenarios. So the first one I want to go, let's look at the controller level. Okay, so let's look at some that often get folks hung up. So we're going to look at VAV box airflow. We're going to look at air handler cooling coils, and then we're going to look at an outdoor air damper reset. Okay, so you get a call and a space is hot, right? So you have to ask yourself immediately, what is going to affect whether that space is hot or cold. Okay, so a lot of folks will approach this all just kind of willy wonky. They'll just go all over the place. They'll be going to the air handler. Do I have cooling at the air handler? Oh, is the chiller on? Is this on? Is that on? Well, that's all well and good, but what you have to do is you have to focus at the immediate problem that's in front of you. Okay, so the immediate problem is that we have an issue with a space being hot. Now, there is some logic in this, right? There is some logic where you have to have a little bit of common sense, which is if every space is hot in the entire building, that will most likely lead you to what? Probably to looking at the chiller, right? Okay. If all of the spaces within a zone served by a specific air handler are hot, that's going to drive you probably to say what? Let's look at the air handler. But, and this is where we're going to focus for the majority of this episode, if you have a specific zone or a specific unit and all other units are operating at design conditions, then you should avoid that temptation to go look at the chiller first or go look at the air handler first. You should focus on that unit. So that's kind of a tip that I'm giving you here that kind of sits outside of this input to output and output to input methodology, which is that if you see all of something being affected, say, okay, what is the all that serves all these things? So if all of the radiant heat isn't working, all of the radiant heat, then you say, okay, what is the most common factor that could affect that? But if a specific system is not working, we want to focus in on that. So in our scenario, we get a call and a space is hot. All the other spaces are fine. So we start off and we say, okay, we've got this VAV box. It's serving this space. What happens? How are spaces cooled? And this is why I said you really should go through that HVAC control sequences fundamentals course, because understanding how spaces are cooled, understanding how systems operate is really going to help you troubleshoot. But we understand that air within a space is changed. The volume of air is changed using a concept called air changes. So you supply air in and you exhaust air out. And that is how we change the volume of air. The air mixes and we get a decrease in temperature, a decrease in humidity in the space by removing heat. All right, or adding heat if we're trying to increase temperature. So the space is hot. Now we first say, okay, from an input to output perspective, what is our first input? What is our first input if a space is hot? A lot of folks, if they're using the input to output methodology, they will immediately go to check airflow, which is not a bad thing. But if you immediately go and check airflow and you bypass that whole zone temperature loop, you could have a PID loop that for whatever reason is turned off or spun up or not operating, and that's improperly driving the CFM set point, and thus the damper never opens. But you'll miss all that because you don't start at the true input. So that's kind of when you're looking at this VAV box airflow scenario, start at that true input, which the true input is the zone temperature set point and zone temperature itself. So we look at the zone temperature. Is it actually working? Is that zone temperature set point actually a set point that could be achieved? These are all questions we want to ask ourselves. Then we go into the controller and we start to look at the PID loop. Is the PID loop operating properly? Is it enabled? Things like this. Okay, if it is enabled, then we go from there and then we look at this calculated CFM set point. Do they have the balancing settings from the balancer who gave them min and max flows for boxes? Are they accurate? Is the box size accurate? All of these factors that we're looking at in our programming. Then we go and we check. All right, so that's all accurate, but we're not getting CFM maybe. So then we go check the CFM sensor. Is the velocity pressure sensor working? Is it plugged? Is it accurate? If that's accurate, then we move to the damper itself. And you see kind of how that all plays out, right? Now, that's all well and good. And you say, but Phil, in this case, it would have been a lot faster to just check whether there's airflow or not, and if that airflow is cool, and et cetera, et cetera. Well, that's why the output to input method exists. So I recommend the input to output method when things are complicated, when there are multiple variables that could potentially affect the operation of a system. If it is something simple like a VAV box airflow, I know I just told you all, hey, check the inputs first, but you can get away with going and saying, you know what? All right, I'm just going to make sure the damper's actually open and stroking, and I'm going to make sure the CFM set point and work my way backwards. You can do that as well. But either one of these, the thing you don't want to do is bounce between the two. You don't want to start with zone temp, and then, I'm going to check the damper, and then, I'm going to go back to the zone temp PID, and then, because you're wasting time, you're being inefficient, and you aren't providing a path, a troubleshooting path. Now, VAV box is a very simple example, okay? It's a very simple example. It's the majority of what you'll probably troubleshoot, along with air handlers and potentially chilled water loops this time of year when I'm recording this episode. But you have to get this idea of a troubleshooting path down, especially when we start to deal with more kind of ethereal pie-in-the-sky things like communication trunks, protocols, IT packets, graphical user interfaces, concepts that we can't physically touch, and they're very much in software. If you don't have this thing known as a troubleshooting path, then you will not know the steps you've made, and you can't trace your steps back to see kind of, oh, yeah, I did check the trunk, I did check polarity, I did check the end of lines, all these things. So if you don't use a troubleshooting path on the simple stuff, I guarantee you will not use a troubleshooting path on the complicated stuff. I know I'm going to get off my soapbox, but that is super duper important for you to do. All right. Okay. So then AHU cooling coils. So input to output. Very easy, right? What's our input that drives our cooling coil? Typically discharge air temp, right? It's typically that, but sometimes it could be humidity. We could have humidity. We could have where we're using an economizer with mixed air temp and driving the economizer with mixed air temp and picking up the slack with the cooling coil. These are a variety of things that could be causing this cooling coil to not work. And so you see, you have 3 potential inputs driving this cooling coil. So if you were immediately go output to input, the cooling coil may supposed to be closed. It may actually have a reason to be closed, but you may miss that because you didn't factor in all of the potential inputs. So we're starting to see that complexity, right? We're starting to see that there's multiple factors, mixed air, free cooling lockout, low temp alarm, humidity mode versus non-humidity mode. There's condensate drain where actually, that coil is really condensing in a humid area, and that drain switch trips, and all of a sudden that coil's not working. There's so many different factors. So in this case, you look at it from an input perspective. You can still look at it from an output perspective if it's like a simple rooftop unit or a simple air handler that doesn't have these additional features. But if it does have these additional features, you really want to start with the various inputs and say, are all of these states true? It's just like checking programming, right? Whenever you're going and doing a functional check and you've got a sequence of operations, you want to check all the different states to ensure that when you operate that state, that the output actually is in the position it should be in based on the states. This is really why I encourage folks to understand state-based thinking, understand what state the unit is in, and understanding what conditions exist to drive that state. Should the unit be in that kind of state based on the conditions that are existing? These are all things you need to be thinking about. And then we talked about demand ventilation, right? Or free cooling. So demand ventilation is a very popular technology, and that is essentially where, so ASHRAE 62.1 requires you to have a certain amount of outdoor air per either space type or people count. And you can actually go and use CO2 sensing to offset this minimum outdoor air and actually shut your outdoor air damper to 0. But then there's also free cooling scenarios, right? So there's situations where you have free cooling scenarios and you want to drive to mixed air temp. So what I can see, and then if you throw in to this airflow measuring, you can start to see a lot of issues occur with trying to control an economizer damper. So you think about it, right? You've got the damper, you've got the actuator, you've got a mixed air temp you're potentially driving to, you've got potentially outdoor air and mixed air flow you're potentially driving to, you've got potentially a return air damper opposing position that you may be driving off of. You also potentially have some mechanical linkage, and you also potentially have CO2. So you have so many potential inputs that are driving this output. So to go straight to the damper, once again, while quick, could potentially cause you to miss a lot of issues. So a lot of you at this point may be saying, Phil, why even teach us output to input if you keep saying use input to output all the time? Well, there are scenarios where output to input is straightforward. It's a great tool to use on simple loops like a unit ventilator, unit heater, things that are simply true or not true. Maybe getting a fire alarm input and troubleshooting that. Enable points. Those are all great output to input because they're linked. The chillers, if they have a single enable point, then you can use output to input. But if they have multiples, you want to use input to output. All right. So moving right along. So now we're going to take a look at this concept of supervisory level troubleshooting. This is where we start to move away so much from the stuff we can put our hands on, and we move into situations that are a little more difficult. And for example, communications trunks. I see this on our Facebook group all the time. I get asked questions in our live office hours. I get asked questions in the discussion post. I get emailed questions about communication trunk troubleshooting. Now, part of this is because some folks don't understand how the protocols work, both from a physical aspect, what's the difference between BACnet versus LAN versus Modbus, what's RS-485 versus RS-232 versus Ethernet, those kind of things. But also, I tend to find that when you're talking about troubleshooting options, communication trunks are full of different options. It could be a short in the wire. It could be a controller's offline. It could be a misaddress. Could be all these issues. And so you say, well, how can I take an input to output approach on a communication trunk? How would I even begin to do that? All right, so here's how you begin to do that. So what would be the input to the communication trunk? Most of the time, it's either coming from a controller or coming from a supervisory device. So what you want to do is you want to pick a point. I will usually start with a supervisory device. And if I have a single controller that is offline or causing communication issues, then I will go and start to work through the communication coming into that controller. What is true? Is the polarity good? Is the wiring good? Those kind of things. It's coming into the controller, okay? And only when I get through the things coming into the controller, then do I start thinking of the things going out to the controller. Okay, so it's came into the controller. Now I'm going to start checking baud rate. I'm going to start checking the MAC addressing. I'm going to start checking maybe any end of line switches, because that's on the output side of the controller. So you've got stuff that affects the data coming in, and then you've got stuff that affects the data coming out. And so that's how I work through this. I also when I start to work with technology, I start to add another layer of kind of troubleshooting approach, and that is the OSI model. You look at the physical layer. So the physical layer is all of the wiring, everything like that, the signaling, polarity, etc., baud rate. Then we start to look at the data link. We start to look at things at the MAC address level. Then we move up to the network level and then to the transport layer and so on and so forth. And this becomes increasingly important as you move in to more server level troubleshooting. So here's where I find that folks can, for the most part, get through controller level troubleshooting. They may have a little difficulty if it requires them going into the programming. It's one of the reasons our programming course is so popular, because it teaches design patterns, and folks are able to look and see the design pattern and know what the program is supposed to be doing. But if you have a fundamental understanding of programming and can read programming logic, you can figure out most controller level issues. You can figure out a lot of supervisory level issues just using a meter and using some of the statistic stuff that's built into your supervisory devices. When you get to the server, this is where stuff tends to get more complicated, because a lot of folks in our industry still have not developed a solid IT knowledge base. And because of that, this is where I am reminded of a data center that kept losing communication every night. And it turned out that they were doing a massive database upload every night from some other software on the same trunk that the BAS was on. And when I say trunk, I'm talking network trunk, not field bus trunk. And they were making this database upload, and the quality of service was causing the building automation data to drop off and go offline. But if you didn't understand quality of service, if you didn't understand first in, first out, and that kind of stuff related to network switching, then you would really struggle to troubleshoot this. So I will say, while troubleshooting is definitely a skill that can be developed at the controller level and supervisory level, when you get to the server level, when you get to that network level, if you don't have a fundamental understanding of information technology, then you're going to really struggle to troubleshoot these kind of things. So that brings me to two of the most common issues related to servers, and that is database issues and UI issues. Sure, there are a lot others, but those are the primary two I see. So with database issues, the primary issues I see are related to ingesting data into the database, so getting data into the database. Once it's actually into the database, oftentimes visualizing the data, running data analysis is pretty easy. So oftentimes when we're troubleshooting databases, we are troubleshooting from an input to output perspective. So we are seeing, are our buffers on our supervisory devices right? Are we pointing to the database? Is the database online? Is it full? Is it licensed? These are all sorts of issues we're working through. Oftentimes an output to input approach will not work very well on database issues because the issue oftentimes is with the input. Now contrast that to UI issues. Oftentimes the issue with the UI is actually the output. So what will often happen when we're having issues with our UI is we are not receiving a response from the server. So there is actually an issue. We're sending the message, but we're not receiving a response. Maybe this is related to actual routing of the message, or a security issue, or a network setup issue, or firewall, but we are not able to receive messages from the UI. And so oftentimes with UI issues, we'll take an output to input approach. Now, with all kinds of technology, you can start to see that if I just approach this willy-nilly, I would be in a lot of trouble. It would be very difficult for me to troubleshoot. So I will tell you once again, the higher you move up on these levels of troubleshooting, the more important it is for you to have that troubleshooting path. Because, for example, I recall I was working on a hospital, and there was a set of software, and this software was running the OR conditions in the OR. And what would happen is, because of the operating system that was running on these touchscreens and the way the program was compiled, it was not managing the memory on the operating system. And so over time, the operating system's web browser would get full of memory and the computer would lock up, freeze, and reset. Now, this was extremely difficult to troubleshoot because it was happening on so many different levels. It required looking at the actual device. It required looking at the touchscreen, putting logs on the operating system, understanding what was being utilized, memory, CPU, disk space, understanding what would be causing this web application to freeze, lock up, and reset, and then actually going into the source code of the web application and looking how it handled these issues. So it was really complex. Now, I'm not going to go through the whole scenario of how we troubleshot that. The point is, though, it was documented while we troubleshot it. Because if we had not documented that, there were so many layers upon layers. Was it the OS? Was it the server? Was it the network? Was it the memory? Was it the application? Was it the web browser? Was it the version of the web browser? All of these different issues going on. And we documented each one so that we knew what was happening as we were troubleshooting this issue. So that is something I really encourage you as you move into more complex issues to document your troubleshooting and have that troubleshooting path. One good way to do this is to draw it out and kind of have that path drawn, kind of like a mind map. If you don't know what mind maps are, go and Google that. It will really help you out. So with that being said, that concludes this episode on troubleshooting. I hope this gives you a perspective on how to troubleshoot. I really look forward to your feedback and input on this. And if you are sitting here trying to figure out troubleshooting and you're finding it very difficult to troubleshoot equipment and systems, I encourage you to check out our HVAC control sequences course at buildingautomationmonthly.com/174. And I encourage you to go and post in the comments and let us know your approach to troubleshooting at buildingautomationmonthly.com/174 or wherever you find a link to this podcast. Thanks a ton, and I look forward to talking to you in next week's episode. Take care.